Alright, sit back and relax and listen to my sleepy self struggle to read this section on the anatomy and function of the heart. I hope it helps you relax and get some good sleep. Anatomy and Physiology Review. The human heart is a fist-sized muscular organ located in the mediastinum between the lungs. Each beat of the heart pumps about 60 milliliters of blood, or 5 liters per minute. During strenuous physical activity, the amount of blood pumped can double to meet the body's increased gas exchange needs. A covering called the pericardium protects the heart. A muscular wall, or septum, separates the heart into two halves, right and left. Each half has an atrium and a ventricle. The right atrium receives deoxygenated venous blood, which is returned from the body through the superior and inferior vena cava. It also receives blood from the heart muscle through the coronary sinus. Most of this venous return flows passively from the right atrium through the open tricuspid valve into the right ventricle during ventricular diastole or filling. The right atrium actively propels remaining venous return into the right ventricle during atrial systole or contraction. The right ventricle is a muscular pump located behind the sternum. It generates enough pressure to close the tricuspid valve, open the pulmonic valve, and propel blood into the pulmonary artery and lungs. After blood is reoxygenated in the lungs, it flows freely from the 4 pulmonary veins into the left atrium. Blood then flows through an opened mitral valve into the left ventricle during ventricular diastole. When the left ventricle is almost full, the left atrium contracts, pumping the remaining blood volume into the left ventricle. With systolic contraction, the left ventricle generates enough blood pressure to close the mitral valve and open the aortic valve. Blood is propelled into the aorta and the systemic atrial circulation. Blood flow through the heart is shown in figure 30.2. Blood moves through the aorta throughout the systemic circulation to the various tissues of the body. The pressure of blood in the aorta of a young adult averages about 100 to 120 millimeters of mercury, whereas the pressure of blood in the right atrium averages about 0 to 5 millimeters of mercury. These differences in pressure produce a pressure gradient, the blood flowing from the area of higher pressure to an area of lower pressure. The heart and vascular structures are responsible for maintaining these pressures. The 4 cardiac valves are responsible for maintaining the forward flow of blood through the chambers of the heart. These valves open and close when pressure volume change within the heart's chambers. The cardiac valves are classified into 2 types: the atrioventricular valves and the semilunar valves. The AV valves separate the atria from the ventricles. The tricuspid valve separates the right atrium from the right ventricle. The mitral or bicuspid valve separates the left atrium from the left ventricle. During ventricular diastole, these valves act as branch descends toward the anterior wall and the apex of the left ventricle. It supplies blood to portions of the left ventricle, ventricular septum, chordae tendendae, I think, papillary muscle, and to a lesser extent the right ventricle. The LCX branch descends towards the lateral wall of the left ventricle and apex. It supplies blood to the left atrium, the latter posterior surfaces of the left ventricle, and sometimes portions of the interventricular septum. In about half of people, the LCX branch supplies the sinoatrial node. In a very small number of people, it supplies the AV node. Peripheral branches arise from the LAD and LCX branches and form an abundant network of vessels throughout the entire myocardium. The right coronary artery originates from the right sinus of Valsalva, encircles the heart, and descends toward the apex of the right ventricle. The RCA supplies the right atrium, the right ventricle, and inferior portion of the left ventricle. In about half of people, the RCA supplies the SA node, and almost everyone it supplies the AV node. The function. The electrophysiologic properties of the heart are responsible for regulating heart rate and rhythm. Cardiac muscle cells possess the characteristics of automaticity, excitability, conductivity, contractility, and refractoriness. Chapter 31 describes these properties in cardiac conduction in detail. Sequence of events during the cardiac cycle. The phases of the cardiac cycle are generally described in relation to the changes in pressure and volume in the left ventricle during filling or diastole and the ventricular contraction systole. Diastole consists of relaxation and filling of the atria and ventricles and comprises about 2/3 of the cardiac cycle. Systole consists of the contraction and emptying of the atria and ventricles. Myocardial contraction results from the release of large numbers of calcium ions from the sarcoplasmic reticulum and the blood. These ions diffuse into the myofibril sarcomere, the basic contractile unit of the myocardial cell. Calcium ions promote the interaction of actin and myosin protein filaments, causing these filaments to link and overlap. Cross bridges or linkages are formed as the protein filaments slide over and overlap each other. These cross bridges act as force-generating sites. The sliding of these protein filaments shortens the sarcomeres, producing myocardial contraction. Cardiac muscle relaxes when calcium ions are pumped back into the sarcoplasmic reticulum, causing a decrease in the number of calcium ions around the myofibrils. This reduced number of ions causes the protein filaments to disengage, the sarcomere to lengthen, and the muscle to relax. Mechanical properties of the heart. The electrical and mechanical properties of cardiac muscle determine the function of the cardiovascular system. The healthy heart can adapt to various pathophysiologic conditions, for example stress, infections, and hemorrhage, to maintain perfusion to the various body tissues. Blood flow from the heart into the systemic arterial circulation is measured clinically as cardiac output. The amount of blood pumped from the left surface area. The normal range is 2.8 to 4.2 liters per minute per meter squared. Heart rate refers to the number of times the ventricles contract each minute. The normal resting heart rate for an adult is between 60 and 100 beats per minute. Increases in rate increase myocardial oxygen demand. The heart rate is extrinsically controlled by the autonomic nervous system, which adjusts rapidly when necessary to regulate cardiac output. The parasympathetic vagus nerve system slows the heart rate, whereas the sympathetic stimulation increases the heart rate. An increase in circulating catecholamines such as epinephrine and norepinephrine usually causes an increase in heart rate and contractility. Many cardiovascular drugs, particularly beta blockers, block the sympathetic fight-or-flight pattern by decreasing the heart rate. Stroke volume is the amount of blood ejected from the left ventricle during each contraction. Several variables influence the stroke volume and ultimately the cardiac output. These variables include heart rate, preload, afterload, and contractility. Preload refers to the degree of myocardial fiber stretch at the end of diastole just before contraction. The stretch imposed on the muscle fibers results from the volume contained within the ventricle at the end of diastole. Preload is determined by the amount of blood returning to the heart from both the venous system, the right heart, and the pulmonary system, the left heart, the left ventricle, in diastolic volume. An increase in ventricular volume increases muscle fiber length and tension, thereby enhancing contraction and improving stroke volume. This statement is derived from Starling's law of the heart. The more the heart is filled during diastole within limits, the more forcefully it contracts. However, excessive filling of the ventricles results in excessive volume and pressure that may result in decreased cardiac output. Another factor affecting stroke volume after load is the pressure or resistance that the ventricles must overcome to eject blood through the semilunar valves and into the peripheral blood vessels. The amount of resistance is directly related to arterial blood pressure and the diameter of the blood vessels. Impedance, the peripheral component of afterload, is the pressure and the heart must overcome to open the aortic valve. The amount of impedance depends on the aortic compliance and total systemic vascular resistance on aortic compliance and total systemic vascular resistance. A combination of blood viscosity, or the thickness, and the arterial constriction. A decrease in stroke volume can result from an increase in afterload without the benefit of compensatory mechanisms, thus leading to a decrease in cardiac output. The myocardial contractility affects stroke volume and cardiac output is the